Algebra 1 students, welcome to your 7.4 notes. Today we're going to look at division properties of exponents. We've already seen multiplication, we've seen power of power, all those things were increasing degree, but today it's going down for real as we do a little division and subtraction. Alright, so let's take a look at the first example here, the big idea. If you have a fraction, something like 4 to the 5th divided by 4 to the 3rd, we could see that we have pairs of 4s that could cancel, like those, and well, one more set right there. What we'd be left with would be 2 4s. 4 times 4, or 4 squared. The way we would get that from the original problem is just finding a difference of the exponents, 5 minus 3. Keep in mind it's always numerator power minus denominator, and as we've seen with power of a power, and more importantly with multiplication, the base has to be the same. So on this next example, 7 squared divided by 7 to the 6th, we could go through and do the same kind of simplification, but essentially it's 7 to the 2 minus 6, which is 7 to the negative 4. And as we've practiced many times, when we get that negative exponent, move it to the other side of the fraction so it's positive, so 1 over 7 to the 4th. Again, it's numerator minus denominator, top minus bottom. Alright, so the general form without numbers, just variables, would look like this. A to the m divided by a to the n is equal to a to the m minus n. Really important concept. Remember, that contrasts a bit with our multiplication where we had a to the m times a to the n equals a to the m plus n. So again, division leads us to subtraction, multiplication leads to addition. That makes sense in a lot of ways. Alright, let's do some simplification here. 3 to the 8th divided by 3 to the 6th would be 3 to the 8 minus 6, which would just simply be 3 squared. Now, depending on the instructions of the problem, we can all simplify 3 squared. I'm going to go ahead and do that and just change it to be 9. Alright, x to the 5th divided by x to the 7th. We follow the same process, find the difference on the exponents, so that would be x to the 5 minus 7, or x to the negative 2. And we don't like those negative exponents, so we will move it to the denominator and we'll have 1 over x squared. Alright, on 3 and 4 we have multiple variables to deal with. So on number 3, a cubed b squared divided by a to the 5th b. I'm going to treat these one at a time. For a, it's a to the 3 minus 5, and for b, it's 2 minus, and remember there's an implied or invisible 1 right there. So this would give me a to the negative 2 times b to the 1st. Now again, we don't like that negative exponent, so we're going to move that a term to the denominator, and when we switch sides, it changes the exponents plus or minus symbol. So in this case it goes from negative to positive, so b over a squared. Alright, one more on this slide. This one's actually a little bit different. We could have done this one before, I suppose. More of a reminder than anything new, but when we have x to the negative 1, we'd want to move that x to the denominator. When we have y to the negative 3, we'd also move that to the denominator and make it y to the 3rd. That left nothing in our numerator, but there's this secret 1 that would go right there. It's kind of the coefficient that's out in front here, even though we don't write it. It's 1 times this. Alright, let's go to some that are a little bit more complex, but we're using the same concepts. Now let's treat this as 3 separate problems. 16 over 12 is one of them. A to the negative 3 divided by a to the 2nd is the next one. And then b to the 6 over b to the 3 is the last. We're going to simplify whatever we can. 16 over 12, 4 goes into both of those. So that would be 4 over 3, 4/3. This is a to the negative 3 minus 2. So I'm going to write it as a to the negative 5. And I know you don't like that negative exponent. We'll clean that up in a second. B to the 6 divided by b to the 3rd is b to the 6 minus 3, or just simply b to the 3rd. Alright, this looks a little funny how I have a fraction out front but not out here. You have to think of the a and the b as both being in the numerator. Now we don't like a in the numerator with a negative exponent, so we're going to move it. So a is now a denominator term, and the exponent is now positive, and b stays exactly where it would be in the numerator, and you get b to the third. All right, number 6, a little scientific notation that we're working with here. 5.6 divided by 7. That could simplify. Now, some of you may want to use a calculator on that. I know this 0.7 goes into 5.6 8 times. So what I have here is 8 tenths or 4 fifths. Although, since we're dealing with scientific notation, if it's 4 fifths, let's write it as 0.8. Some of you may have said, well, hell, I could just do 5.6 divided by 7, and I'd have 0.8, and I don't know what you were talking about, and that's great. If you did that and thought ahead, that's lovely. Keep doing that. All right, then 10 to what power? Well, negative 7 minus 3, that's negative 10. That looks great. Everything's right, except note the scientific notation situation. We have 0.8. We need to move that decimal one place. If I make this number larger, which is what I'm doing here, this number's bigger, I better counteract that by making that number smaller. So I'm not changing the value of the number, I'm just changing the way it looks. And if I move this one decimal place, I need to change this by 1. 1 smaller than negative 10 would be negative 11. There it is. All right, same kind of deal on number 7. 7/8, the decimal, and you may want to use the calculator on this, but that would be 0.875 times 10 to the, and then we got 4 minus negative 3, that would be 10 to the 7th. Again, we have the situation where we need to move that decimal, and again, we're making our A term, our lead term, larger, so we need to make this term smaller. That moved 1 decimal place, so I need this to be 1 smaller. It's 10 to the 6th, and now we have it in proper scientific notation. All right, on to our last slide of today's notes. We have a few things going on these problems. We've talked about this a lot, but we have to deal with this negative, that's a pretty bad arrow, but we need to deal with this negative exponent before we really do anything else. So what I'm going to do is I'm going to flip or reciprocate this fraction. Just so I can lose that negative. There's no reason for me to have a negative exponent there. Sorry, my handwriting is going terrible here. That looks slightly better. There's a random point right there for you. But I've reciprocated the fraction. This is going to be a little easier to work with. Now, we kind of have a decision to make. Do we want to apply this exponent to everything first, or do we want to simplify? It's really a judgment call. To me, I prefer to simplify if I can, and in this case, I'm going to do that. However, I wouldn't blame you a bit if you wanted to apply the square to all these terms and then simplify afterward. So I'm going to simplify within the group and then apply the square. All right, so basically 5 over 2, we can't do anything with that. We'll just leave it as 5 over 2. But x cubed divided by x squared is just simply x to the first. Okay, and we still have that square that's applying to everything. So I'm going to go and basically just square these terms individually. 5 squared is 25. X squared is, well, it's x squared. And 2 squared is 4. And our answer would look like that. Now again, had we gone the other way and applied the square before we simplified, it would have worked. It would have taken a little different pathway, but we'd get to the same place. Now sometimes it doesn't matter if you take the square or the exponent first and then simplify, or the order isn't that important on number 8. On number 9, I would argue the order is pretty important. If you're like me, you don't want to have to deal with 36 to the third power. That does not sound even slightly fun to me. So I'm not going to deal with that. I'm going to simplify first. So I know that 9 over 36 is the same as 1/4, and then t to the 2/3 minus, or sorry, divided by t to the first would be t to the negative 1/3. And remember, this whole thing still has to be cubed. this is where I would go ahead and apply the exponent. And some of you may debate, like, should I go ahead and move this t to the denominator? That would be fine, but I definitely think you want to simplify 9/36 before you take the third power. Okay, so 1/4 to the third is 1 over 4 times 4 times 4 would be 64. T to the negative 1/3 to the third, that's the situation where you multiply exponents, so that's t to the negative 1. All right, so let's clean this up one more step. I need to move t to the denominator, so it would be 1 divided by 64t. Folks, I hope what we're doing here makes sense. Make sure you come to class ready to work, ask lots of questions, and we will see you soon